With the development of the electric car in particular, there's the plastic content in the vehicle has increased significantly over the last few years. So when we're looking at the process, we're kind of looking at from a software standpoint, and from the reality is we've got mold cooling that we're dealing with. We're trying to create a uniform temperature of the mold surfaces before we actually inject the plastic into it. One of the things we've done is we've developed a relationship with the material manufacturers directly. And so if one of their materials are not in our database, we typically can get it very quickly from the manufacturer, so that you can go ahead and run your process with a particular grade you're looking for.
So in order to capture the FRP behavior properly in Abaqus, we have a multi-scale material model. So we can perform a homogenization to homogenize the property and use it in FEA analysis. So in a chopped fiber composite, that's FRPs, we can see that the fiber direction can be represented by these angles. So Abaqus, the multi-scale material is supported both in keyword format and also in 3DX in the material definition app. This is just a simple example showing an engine cover model. We have a finer mesh used in injection molding.